Hi guys, Jake from Real Robots here. Something a little bit different today. We're going to make a game. I was playing a little bit of Simulator or Simulation Farm Simulator 2021, and it was pretty fun. I always like farm games, but I found it didn't really hook me. It wasn't the kind of thing I was looking for. You just sort of plonk down the buildings, you plonk down this, you plonk down that. It was all a very sort of a rigid experience. And what I really wanted was something like a farm, well, more like you have a simulation of a farm, and then you affect it from there. So what I'm going to do is I'm going to make a game, and I'm going to make it like a prototype. So I haven't really planned it out yet. I do this quite a lot. Sometimes I'll make a game like this, and I'll end up finishing it. And I've published a couple and done okay, but most of these just get thrown away. But I thought I want to make a game like this, and I'll record it this time. And if you guys like it, maybe you'll get something from it. You'll see sort of the way I do things. Don't know if it's much better than anyone else's, but maybe you'll enjoy it. So here's the plan. I'm going to make just a simulation of the farm first, and then I'll work out where the game comes from later. So we're going to simulate the farm. So the first thing I'm thinking is just a big flat map. We're not going to think about having terrain deformation or anything like that. The map's going to be a simple grid. And there's going to be grass growing just in squares. We could get more granular later, but right now it's just going to be growing in squares. And the grass is going to grow, and then we're going to have some cows, and they're going to get hungry. They're going to find the nearest grass. They're going to eat it. When that bit of grass gets too low, they're going to move to the next bit of grass. And so you can sort of imagine how by doing that we could, not too much difficulty, get some sort of ecosystem going, where if there's not enough grass, the cow's going to eat it all, and then he's going to starve to death. Well, we're probably not going to have starving to death mechanics in yet, but by balancing sort of how fast the grass grows and how fast the cow eats, we can sort of make a balance. So when that comes to be a game, you may find, all right, I'm going to have a herd of 100 cows here, and I need this much grass to grow them. And of course, there'll be things, maybe you can have different kinds of grass, and you can look after the grass better, or you can have more rain, less rain, or you can supplement them with feed. And then aside from grass, we can have crops later on. But for now, we're just going to make grass growing in squares, and we're going to make some cows that eat the grass. Nice and simple. And we'll just do it from there, and we'll see how it goes. And maybe it'll be a game, maybe it won't. So let's get started. Now I'm making it in Unity, so install Unity, do all that, and I'm going to make a new file. And what will we call it? Just call it Farmer Sim. We're not thinking about marketing yet, so let's keep it simple. And then we'll wait for him to load up. And the first thing I want to do is just put in a nice big flat map. I'm not going to put in anything pretty at the moment, so we're going to make a beautiful grid. So first I'll just start by making a folder here under Assets. And I'll just call that Art. And for the moment, that'll be where all my sort of meshes and images and stuff like that goes. So to make the texture for our grid, I'm just going to open up, I've got GIMP here. I'm going to make a new image with a image size of 128 by 128. And what I'm going to do is just... let's make it white to start off with. I'm going to make a new layer, and I'll draw my grid on that next layer. So I'm just going to grab the pencil, switch to black, and just work out how thick do I want these grid lines to be. And you can actually do this the way I'm doing, drawing a square around the outside, or you can just do it as a cross through the middle. Because it's going to be repeated on the 2D texture, it'll still be a grid. So I'm just going to do the outline like this though. So I'll have a nice thick black outline. So this will be sort of a 1 unit Unity square. And I think what I'll actually do is I'll make a sort of sub-grid as well, sort of half grid. Let's see. I'll do this just on another layer. So layers are cheap. And just to help me get it in the middle, I'm going to add the grid and get it to show me those internal lines. I don't have to measure it. So my image is 128, so I just make the grid 64, and now I've got the middle. And that's 1 pixel, so I'll just put it off to the side there. And you see I've got my layer on top, so I'm just sliding that layer underneath. Yeah, that'll make a nice, just a little half grid. And that's it. That's my grid texture. So I'm just going to export that. And I'll say that as grid.png. Don't need to change anything on it. And I'm going to drag that into my art folder. You can see now I've got the texture in there. So I'm going to create a material. And let's just call that matte grid. Apply the grid to it, my grid texture to it. And let's add a 3D plane. And let's give it a funky name. Let's call it ground plane. And let's apply my material to it. And you can see it's got the grid on there now. And I want to make this massive. So just, we're not setting the boundaries yet. So just something sort of, as far as the eye can see, is 100 by 100 for now. That's on X and Z. Remember, Y is up and down in Unity. Add 1 and 1. And we're going to tile it. So 100 and 100. And now I've got no idea whether that's actually set to one Unity unit. So what I'll do is I'll just drop a cube in here, 3D object, drop in a cube, and it's still not helping because I don't know really where the cube is. So I'm going to move that to a 0, 0, 0 position. And there you can see actually my grid is massive. So let's tile that to 1,000 by 1,000. And that's much better. But you see my grid is sort of through the center of my 0, 0. So I'm just going to shift my whole grid just to 0.5 and 0.5. So now you can see our 0, 0 point is in the middle of the square now, rather than being between squares. So that's it. We've got a beautiful grid. So let's create our first grass. So I'm just going to create an empty object here and then apply a cube to it. So the cube's going to represent the 3D model for it, which I haven't made yet. Now make sure that's set as a sub-object at 0. I actually forgot to add the cube to it then, so let's try that again. So first make sure the grass parent object is at 0, 0, 0. Same with the cube. So that's it. And so my plan is that this cube will be our grass. So first we'll set it to a much lower scale. Let's say like 0.2. Is that how high we think grass would be? And so its position is going to be at 0.1, sort of half of that scale. Now let's create another material. We don't need a texture for this one. We'll just make it green for now. Let's call that matte underscore grass. Apply it to there. And just add that green color to it. Oh, that's very photorealistic grass. That's beautiful. And that's so the plan at the moment is for the grass just sort of move up and down or expand up and down. And that's how we'll represent it sort of growing and being eaten. So let's just name that model there, the grass, not matte, that's the grass mesh. And so we can easily replace that with a much better mesh later if that's what we want to go with. Maybe this will be the final graphics we use, who knows. So now let's create our cow. So I'm just going to hide that grass for now. So same thing, we're going to have the cow sort of parent object at 0, 0, 0, and we'll add a sub object with the mesh on it underneath. So make sure we move that to 0, 0, 0 as well. Make sure it's actually parented to the cow. And because it is just a prototype, I could just sort of make a block and call it a cow, I suppose. I don't know, it's not really doing it for me. And what have I done there? I've pushed the wrong button. But let's make a 3D model. Now I'm actually going to do it in Fusion 360, which I definitely don't recommend. But I do a lot of engineering, so I'm pretty good with this. So I usually use this for doing my little polygonal tests and programmer art. So I'm just going to sort of draw out a 1 by 1 cube here. If you know how to use Blender, use Blender. Don't use this. This is really just for drawing like mechanical models and things like that. It's just what I'm used to using, so that's what I'm going to use. So there's that's just there, so I can go like 1 unit. Let's call it 100. So I'll call that block, and I'm going to create another one, and we're going to make this to be the cow body. So I'm just sort of roughing it out. Yeah, I think that's how big the body should be. Make sure I don't join it. And I'm just going to now move this to the middle. So I'm just sort of click there, we're doing like a point to point move there. So that's centered, and now I'll move it up, probably about that high. Yeah, that looks nice. Let's give him some legs. Yeah, that's about right. Looks a bit leggish to me. Slide that one down so it touches the ground. Oh, that's gorgeous. Make sure we don't join yet because we don't want to join to the base. And let's just copy and paste 2 legs. Now, most cows I've seen, I don't know about you, they usually have 4 legs. So let's give him another 2. Very nice. Now let's get really fancy. Let's give him a head. That's about the size of a cow head, isn't it? You'll see I'm sort of building everything sort of off to the side, and that's just because it's just really easy to build it and then center it using this little point-to-point center thing. So that's just the habit I'm in when I'm roughing stuff out. Oh, look at that. This is looking more and more like a cow every moment. Let's give him some horns. I think horns will really take it. Even if, do female cows have horns? I don't know. Maybe that's something we should look up if we're making a farm game. But I think putting horns on it will really just get across the idea that this is a cow and not just some weird cube creature. And so I'm going to get fancy now. I'm actually going to mirror those horns. So we've got some on the other side. Look at that. That is very cow-like. Head should be a bit bigger, I think. Actually, those horns are a bit small. What I'll do is I'll merge those blocks together now, and I'll just scale that horn up a little bit. It's just looking a bit small to me. Just scale it up. Yeah, that's about right. So now let's delete the other old horn. Ah, that's right now. I'm not going to delete, I'm going to remove them. Fusion 360 doesn't like when you delete things. Make sure that's actually in contact. Alright, what else do we need? Tail would be nice. It's about the middle. Tail sticks out a little bit. Oh, that's not centered at all. Let's center that tail. Drop him down a little bit. Now what I'm going to do is extrude a little cube off here. And then just stretch that cube down so we have a nice hanging tail. Usually the tails hang down. And I don't know, do cows have like a little tuft at the end? Let's give them a little tuft at the end anyway. I think that'll look nice. Tail, is that a bit long? Let's mirror that horn and see how we look. I think the head should be a bit bigger. What do you reckon? From a distance, a cow? Yeah, I think I'll shorten that tail a little bit. Just move that little cube up a little bit. Oh, yes. That is a cow. So I'm just going to combine all these objects into one mesh. Once again, unless you're making something this simple and stupid looking, I would not be using Fusion 360 for making your character models. But, yeah, I think that's come out pretty well. So let's, now one thing with Fusion 360, you can only export this to STL. And Unity doesn't really do STLs. So I'm going to save that. And I'm actually going to use Blender to convert my STL into an OBJ file, which Unity likes a bit better. Now it uses a slightly different coordinate system, so we're just going to have to rotate X 90 degrees. There we have a cow. It's probably too big, but we'll do the scaling in Unity rather than here. So now we export to a wave front OBJ. And not much to do here, just make sure it's not as a group on the right. Just sort of make sure all your tick boxes on the right are the same as mine. And I'll just save it straight into my art folder and we'll call it cow.obj. Now if I jump back into Unity, there is my cow model. Let's drop him in, and he is enormous. So let's just change that scale factor on the cow mesh to 0.01. That's much better. Still a bit big maybe. So I'm just going to apply that to my cow sort of parent object there. So my cow mesh is sort of a sub-object to an empty cow object. And the sort of parent object will be handling all the scripting and moving and AI and things like that. Yeah, maybe a little bit big. Let's just scale it down a little bit more. Let's call it 0.08, so like 80% what it was. A bit better. Maybe 7. Yeah. And you know, we can work in something later, so when they get fatter and older, they get bigger and the babies are smaller. But for now, that's a good size for a cow, I think. And let's make a nice cow color. And we're not going to, of course, texture them right now. We're just going to make them black. And we'll add the white spots and the... Oh, we should have put a bell on them, like a little golden bell. Maybe later. But that's definitely looking cow-like to me. And yeah, when we put a few there, they look sort of like cows. Now, just make sure, I've done the wrong thing here, just make sure we don't move around the cow mesh. We want to make sure we always move around the cow parent object. So I'm just going to, yeah, that looks pretty good when it rotates. So I'm just going to make sure his relative position is 0, 0, 0. His position is 0, 0, 0. And now we've got a cow. Let's move him back to there. Let's just save our scene. Alright, so we've got our basic objects in there. Let's have a look at the code. So I'll just make a folder for scripts just to start off with. And let's create a C# script. And let's call this pawn. So pawn's going to be like my basic sort of dude that moves around. So later on I can extend this into characters that move and different animals and all sorts of things. But let's just make a basic pawn to start off with. And we'll give it our cow AI. So first, I'm just going to give it some basic movement. So let's give it a turn speed of 1 and a movement speed of 1. And I'll just put in a vector 3 here to save its current movement target. And just default that to 0, 0, 0. And let's make a little function just to make it turn to target gradually. So I'm going to first store in a vector 3 the direction to his target. So sort of the angle between, the direction that I want to be facing. So the target direction equals the movement target minus my current vector position. So that'll give you a vector pointing towards where you want to be. So that's sort of that angle I want to be facing. Where transform.forward would be the angle that I'm actually facing. Now I'm just going to store in a little float here the amount I want each step to be, which will just be my current speed times a delta time. And then I'm going to calculate what our new direction will be after this update. So we just do a vector 3.rotate towards our current forward transform to the target direction, and then our step. And I'm just going to draw a little line out just so I can always see which way I'm facing. Just for fun, we don't really need this, so that's a debug.drawArray from our current position out in the direction, and by default it'll just go out by 1 unit. And then we set the rotation of our object And we need to use the quaternion.look rotation to convert it from the Euler, the sort of XYZ, to the weird quaternion thing. So it's just look rotation, and then we input our new direction. And so then as we do the update, step by step, we'll gradually turn to the position, the direction that we want. So let's just make sure we've got that script on our pawn, on our cow. And at the start, he's just pointing straight. Whoops. So if you look at my cow position, I've actually, let's see. So the cow position is correct. But what I've actually done is I've got his sub-object not at 0. Yeah, that's the one. So that should be at 0. All the sub-objects should be sort of at a relative position of 0 compared to our main cow object. So let's move that back. It's a bit tricky because when you actually click on the mesh, it's going to select the sub-object. So you've got to be careful with that when we're doing it this way. So he's pointing straight, which is what we want. And if I move that target, you can see he's moving. So if I set it back to 0, and if I put it back here, that's actually going to be behind him now. So now he can turn to face. And of course, he'll look up and down if we move the position on the y-axis as well. All right. So now he can turn to the target. We need him to move towards the target as well. So let's create a function called move to target. And so I need to grab the current position plus the forward direction times the movement speed times the time delta time. So that's just a little, that's like our turn step, that's our move step. So it takes that forward direction and just breaks it into sort of a time-based, sort of moves based on how much time since the previous iteration of time. I'm saying that really badly, but let's keep going. So I'm going to store the angle to target, because what I don't want him always moving forward. So after I've turned to target, I'm going to just store the angle to the target. And the reason I'm doing that is because I don't want him to move unless he's facing in the right direction. So if the angle to the target is 90 degrees, I don't want him to move forward yet. So if the angle to target is less than, say, 10 degrees, and the distance is still far enough, so the distance between the current position and the target position, so the move target dot position, if it's greater than or equal to, let's say 0.2, that's close enough, I think, then we'll move forward. So he's only going to move forward if he's looking at the target and if it's not too far away. So let's just drop that in our update loop after our turn to target. So he's going to turn and then move if he should. And let's see how that works. So yeah, he moves. That works. So if I move that position now, he's going to turn and then walk towards that. Glide towards that. Move back to 0. He's going to turn and move to there. And back to 0 again. I'm just going to change that turn speed just a little bit. Let's move it up to 3. I don't know if that's more realistic. It's hard to tell when we don't have other things in the game yet, but let's keep it at 3 for now. There we go, very realistically moving cow. Now remember, whatever changes you make to these attributes while it's running won't be stored, so you've got to do it again while it's not running. Alright, so now that I've tested that and that works, I'm going to make a quick change. So I'm going to change the move target to be a transform, because in the future he's going to be moving towards an actual other object, not just a vector 3. So let's just change the move target to be a null transform, because we don't know where he's going yet. And then everywhere you've said move target, it's going to have to be the move target dot position. So we're going to get the position of that transform. All right, let's drop the grass back in. So turn that back on. And now set the grass as our move target, and let's just make sure that works. So now the cow moves towards the grass and stops when he gets to the grass. Gorgeous. All right. Now I'm going to create a folder for prefabs, and I'm going to just store that grass as it is. But before I store a saved version of that grass, let's do the script for it. So create a new C# script. We'll call it grass. And our grass is going to need, let's call it health. This is like how much sort of grass is left in this square. So this will go down as we eat, and it sort of will go back up again to a max of 1 as it grows, I think. And let's just store the transform of that sub-object, the grass mesh. That'll just make it a bit easier to sort of scale it and fiddle with it. So on the start, we're just going to grab from the transform the first child, which it's not the best way to do it, but since there's just one object there now, that's a nice quick way to do it. So let's just make a little function to update that grass mesh as we change the health. So that grass mesh transform, we're going to change its local scale. And so regular size would be just 1, 1, 1. And what was our default? It was 1 for X and Z, and then Y was 0.2. So it's going to be 0.2, 0.2 times our health. So when the health is 1, it'll be 0.2. When the health is 0.5, then the size is going to be 0.1. And the position, we want to move that sort of down a little bit, so the bottom's always touching the ground. So for position, local position, sorry, it's always going to be 0, 0, 0, except for this one, which is going to be, so it starts off as 0.1. Actually, that's basically, it's always going to be half of the local scale. So let's just drop that in there. So half of the local scale dot y. So now whenever I update the mesh, it'll adjust that for me. Now I've got an error. Let's see, can't change vector 3 to a float. And I just forgot to put the dot y at the end of that. We're trying to grab the whole vector local scale. So position y is going to be local scale y divided by 2. Yeah, that's right. Always going to be half. So now, as I change that health, you can see the grass changes its height. Won't go below 0, that's fine. Can go above 1, that's fine. Probably we'll lock that in somehow later. Alright, now we don't want to do that every update because that's sort of a waste of resources. If we've got 1,000 grass, you can imagine doing that 1,000 times. This is going to be very wasteful. So we'll just make sure that updates when we change. So let's make a function for when the grass is eaten. So this will probably be called by a cow. So we'll just remove a bit from the health. Make sure we apply the delta time so the timing's always right. And we'll update the mesh after a change. And do make sure that eat grass is public, because that's going to be called probably by the cow, which is obviously not inside this script. Alright, let's create another script. And I'll just make a map script, sort of like a game master. And that'll just store all the positions of my grass. So let's, before we go and test eating the grass, let's make a whole bunch of grasses. And making a whole bunch of grasses will be handled by map script. So first, let's make a list of grass objects. Let's call it grass list. So list is a nice little array that we can just always add stuff. We can change the size as we go. And let's just make a little function to generate a bunch of random grass at the start. So let's see, generate random grass seems appropriately named. And we'll start with a counter. And so we're going to have 16 grasses. And what I'll do is I'm just going to make a little for loop. And let's make it 64. I'll explain why we're doing this in a sec. So first we're going to make a random position. So let's just make it in a short area. So between -8 and 8 on X and Z. Y is 0 because we're not going up and down yet. And what I want to do is make sure that there's no grass put at this random position yet. We don't want to be stacking up grass. So if there is grass at this position, then we'll generate some grass. So let's just go and make that grass at function now. So it's going to be a Boolean. We're going to feed it a vector3 position. And it's just going to go through each grass in our grass list. So for each grass in grass list, if grass.transform.position equals our pos and return false. And if we get all the way to the end, we can, actually that's the wrong way around. So if there's something there, we're going to return true. So there is grass at that position. But if we get all the way through the list and there's no grass there, we can say false. There's no grass at that position. Now I'm just going to store our grass prefab here. So when we generate it, we'll make copies of this grass prefab. So the grass should just be this object here. We've put the script on there. We've put the mesh on there. And then let's assign that to our grass prefab there on our map. Make sure you've got the map script on your GM. And then we can do this. So game object, new grass equals game object dot instantiate. Now this is actually a really slow function and a really slow way of making objects. But this is just going to happen at the start, so it doesn't really matter. But this is the kind of thing where you don't want to be doing this every frame. So we instantiate the grass fab at a position of its own quaternion, its own angle. So we don't need a special direction. And then we add it to our grass list. And make sure you add the grass component, not the actual game object. And then we subtract 1 from our counter. And if our counter equals 0, we can break out of our loop. Because we only want to put in 16, not 64. So the reason I've done it like that, you could have done a while loop. So we could have gone while true, and the loop will keep going forever until we've done 16. But that carries the danger that if I was doing a different size, or if we kept getting, for any reason we couldn't actually get down to 0, we couldn't, we keep getting random numbers that there was already grass there, or maybe one of our functions, our grass hat, was failing, you'll get locked there forever. So I like to do it with a nice little loop like that. So maximum will be 64 tries. Yeah, and then we get a nice random bunch of grass. Not bad for a start. All right. So let's just add a bit of randomness to our grass. So whenever a grass is spawned, we're just going to make the health, instead of being set to 1, it's just going to be assigned a range between 0.8 and 1. And then we'll update the mesh after that. So we generate our grass. And we click them, and you can see the health is sort of random. It's not really enough. I can't really see much of a difference there. We might revisit that later. Probably when the grass is closer, it'll be more obvious. But let's not spend time on graphics and little things like that now. Alright, so we need some AI for our cow now, so he'll seek that food. So let's just go void AI. It's going to be a simple AI for now. So first, we're going to find the nearest grass. So let's break that into a little function. Void find nearest grass. And it's the map that knows where all the grass is, so let's use that. We could use like tags and like search the whole map for tags, or search the whole game for tags, but I like to do it sort of centrally like this. So we're going to store the map, and the map is going to be grabbed at the start by doing a game object.find. And we'll just go map.get nearest grass, and we better feed it our position as well. So going back to map, and we better add that function in. So it needs to be public. It's going to return a grass object. It's going to be get nearest grass, and we feed it a vector3. So this is going to check all the grass and find the nearest one to the position we give it. So first we just need to store, to do this little sorting algorithm, what's the closest one we've found so far, and just set that. Something massive. Store the closest one we've found so far. We haven't checked yet, so it's going to be a null. And then for each grass object, we'll call it grass in our grass list. If now to get the distance between two vector3s, let's store the distance first. So we're going to store the distance and go vector3 dot distance between our pos and the current grass transform position. So we'll store that distance, and if that distance is less than the closest distance we've found so far, then we'll store that as our new closest distance, and store that closest grass as this object. And at the end, we'll return that closest grass. So if it never finds one closer than 9999, it'll return null. Tell you what, let's add one other thing. And let's say the grass has to have a health of more than 0.2. So if the cow's already eaten that grass, he won't just stay at the same one. Once he's eaten it down to 0, that one won't show up in the search. So he'll go to the next closest one that has grown back or was never eaten yet. So let's store that nearest grass in the move target. So let's store that. So let's go closest grass is grass, because it's a grass object, it's not a transform. Now if the closest grass is not null, so if we actually get one, we're going to set our move target to be that closest grass's transform. And let's just, because there's sort of two options, because once we get there, we want to be eating it. So let's just go make a Boolean. Are we eating? For the AI later, we'll have to have a much more complicated state machine than this, but let's just right now, is he eating? Is because if he's not eating, he's going to be walking to grass. So he's either standing there eating or he's walking to grass. So if he's eating, he'll eat, or else he needs to find the nearest grass first. So actually let's go. So if he doesn't have a move target yet, so if he hasn't found some grass, he needs to find the nearest grass. Or else if he's already found some grass, then he needs to move towards it. So we can just take our turn to target, move to target, and drop them in there. So if he's not found some grass, he's going to find it. If he's found it, he's going to move towards it. And then let's make sure there's a way to break out of this. If the distance is sort of between his position and the target, then we'll set is eating to true. So then he won't move anymore. He'll go straight to eating. What have I done? Oh, I haven't put the comparator. So distance is less than, let's say, if he's closer than 0.3. So the move to target brings him to within 0.2. And this will switch him to eating when he's within 0.3. And let's make sure we call that AI as well. So let's see if that works. And he should just walk to the grass. He should find the nearest grass and walk towards it. That worked. Let's move him somewhere out of the way. And he points towards the grass, he moves towards it, and he stops. That looks like it works. So let's let him eat the grass. So all he needs to do is, we need to grab that grass, his current grass. Well, we haven't stored the actual grass class, so we need to grab it from the move target, which is a transform. So we get the component grass, and we eat the grass, let's just say by 1. So we've already got that eat grass function on the grass. And then let's say once it's not great to be getting the component again, we should store this somehow, but let's just say get the grass, and if its health is less than 0.05, then we've eaten it, and we'll set is eating to false, and we'll just set our move target to not false, to null. And so then that should kick him back into the not is eating mode and tell him to find the next grass. So he finds the nearest grass, he eats it, and he goes to the next. He eats that one, and he finds the next closest. That is working. Isn't he cute? Oh, he's a hungry boy. And what's he going to do at the end? Yeah, nothing. So he'll just be every frame looking. And it's going to be a bit inefficient, every frame searching and searching through the whole list again. But it's fine for now. Not great if there's 100 or 1,000 cows. But with one cow, that's not going to bother us. So we're not going to fix it yet. Now I would like if the grass grew back. So then then we have a simulation that can keep going. So let's make a function for growing, and I'm setting it to public. I'll tell you why in a minute. So if the health is less than 1, then the health will add, let's just say, what's a good amount, 0.05, and make sure we lock that into the delta time, and make sure we update the mesh after we do that as well. So we can put that in our update. If it's going to be going every time, we should make it a bit less, maybe 0.2. But let's, instead of updating it every frame, let's go back to our map, and let's have the map update all the grasses. So I'm going to set a float to record the last time we updated grass. And I'm going to do this little thing. If our current time minus the last time we updated is more than 1f, so more than 1 second, then we'll go through each grass and we'll update it. So we're not updating the grass every frame, we're going to do it once every second. And later on, if there's lots of grass, we can break it, so we'll update 10% of the grass every 0.1 second, so it's spread out. Let's see if that works. And so he's going to go, he's going to eat the grass. And the grass is growing back faster than he can eat it. That's not great. Well, great if you're the cow, I guess, but not great for us. I can see what I've done. I've actually not stored the last update, so it's running every frame. So we have to make sure we actually store the last time we ran the update. So now it'll run every second. It was running every frame before. So he eats the grass, he moves to the next one. And if we click there, we can see every second it comes up just a little bit. So we can do the math on that and work out like how fast it's growing. But for now, we're just getting the functionality. So we can even see it growing. Isn't that nice? So not as smooth when we do it once a second. So we may not want it going like that just for aesthetic purposes, but we don't know what kind of graphical sort of style we're doing yet. So we may want like a nice little chunky thing like that. But we can see he's clearing out all this grass much quicker than it's growing back. So let's go and tweak that a little bit. And we could make the grass grow quicker, but we can also change the speed that he eats it. Where is it? Here. So when he eats grass, we're feeding that number in. So let's make that 0.2, so he only eats 20% as fast. So now, still pretty fast, but maybe a little bit more realistic. It's going to depend on how we want the game to be, whether it's going to be a sort of real time or a sped up time sort of thing, which I'm not sure yet. But for now, I think we've got our basic like functionality we wanted to do today. We've got a cow who eats the grass grows back. And we've got the beginnings of a farm simulation. I'm not sure what the game is going to be yet, but we can build the systems and then see if we can make a game out of it later. For me, just making the system sort of the fun part. So thanks for watching, guys. I hope you've gotten something out of this. If you do have any like better ideas for how I could have done things, please let me know, because I'd love to hear them. Because like I said, right now we're not looking really for the best ways to do things. We're just doing the fastest. But if we're going to make a game out of this later on, we'll want to know the best way. So make sure you let me know in the chat below. But for now, let's watch this hungry boy eat up all that grass.